This one looks similar to those two, doesn't it? Unilateral localized water density mid to upper right lung field, but it doesn't go all the way where?
To the apex.
It doesn't go all the way to the apex, and I can see the minor fissure all the way over, but there's a little bit of density right below it. Do you see that?
Mm-hmm.
Now look at the difference in the border. You see how this is a well-defined border? What kind of border does this have?
Ill-defined.
It's a fuzzy, poorly defined border. When we have all of the acini and none of the acini involved, all, none, is a well-defined border. All of the acini being filled up against none of them being filled up is a well-defined border. Does that make sense? Okay. All, some, none gives us a fuzzy border, doesn't it? So we have all of them filled up, then only some of them filled up, and then none of them filled up. All, some, none is a fuzzy transition. All, none is a well-defined boundary, and that's what you get up against a fissure. Now, if you can see the fissure over top of this density, are they touching each other?
Mm-mm.
So, is this density in the middle lobe or in the lower lobe?
Middle lobe.
Okay, if it was in the middle lobe, it would be on the other side of the fissure. So then you'd have water density on this side of the fissure, water density on this side of the fissure. How could we see the fissure? Can't.
It's lower
You
lobe.
can't. You can see the fissure here if the density's back here, though, because then you've got air below the fissure. This is not a silhouette. If you've got water density on both sides of the fissure, it's a silhouette sign. But when it's behind it, no silhouette, because this is not a silhouette sign. This is a silhouette sign. This isn't. So if we can see the fissure all the way over here, we know this is not in the middle lobe. This is not number 5. It has to either be in 7 or 10. Does that make sense?
Isn't that too high to be 7 or 10?
Mm-mm. 6 goes up here. 6 is basically kind of above the minor fissure.
Okay.
Yep. So this, going from front to back, is 5, 7, or 10. Since we've assumed, since we can see the minor fissure, it can't be in 5. So it's got to be in 7 and 10. There's no way to know that without the lateral. Doesn't go all the way up here. You see how the transition is a fuzzy transition? Well defined, poorly defined, because there's no fissure up here. There's no fissure separating 1 and 3 or 1 and 2, is there? No. Also, if you look very closely, can you see the little faint branching tubular lucencies in there? That's because the bronchi have air in them, which is called an air bronchogram sign. It just means that there wasn't enough canals of Lambert involvement to fill up the airways also. This is a pneumonia, just a little bit earlier than those two, but the same problem. This is a right upper lobe pneumonia, just earlier than those two. Give this patient another 12, 24 hours, it'll probably fill up number 1. And that's mostly the result of pores of Cohn do that, because the exudate just seeps through the peripheral air spaces doing that. This up here is water, plasma fluid. You see how there's too much density right in here and right in here. This is a different configuration, though, than these 3, isn't it? Yeah. This is a different configuration. This looks like it's kind of going like this, doesn't it? Kind of from the center and going out like this. And you see how the peripheral lungs clear out here?
Yeah.
Also, very fuzzy transition, isn't it? Not completely homogeneous, but this is certainly not normal density. This is kind of coming out like this and coming out like this. This is water, which is plasma fluid. This is pulmonary edema. And that's simply an imbalance between the leakage of plasma fluid and the absorption of plasma fluid. And it's a very common disorder in human beings, especially as we get older. Pulmonary edema is a very common problem. If you die a normal death of old age, you will die with some pulmonary edema, because you'll die from heart failure usually. And as your heart slows down and quits and one side can't keep up with the other, your lungs fill up with fluid and you get pulmonary edema. Very common pathology. Causes major dyspnea. Makes it very, very difficult to breathe. Pulmonary edema. Because they're basically drowning in plasma fluid. That's what they're doing. And remember we talked about Big Orange and how those peripheral lymphatics are a little bit better able to keep the lung clear out there. All right? So this is water, plasma fluid. This is pus, exudate. Pus and water cause most airspace consolidation. Blood is next, and that's either from traumatic or non-traumatic bleeding. Okay?